Okay, here we go. Okay, so my name is David Maroney. We have our co-chairs and also our co-speaker, primary speaker of the session, Ken Kehoe, and we also have a co-chair facilitating us, Yak Xing Wei, who happens to also be the new chair of the Information Quality Cluster, which is responsible for basically organizing this session, co-organizing it along with Ken Kehoe. So a little bit about the Information Quality Cluster. We started it in earnest, I would say, in the summer of 2015 and established a vision that you can see at the top. I'm not going to read it aloud, but our vision statement is pretty much has been the same since we've started. And I believe it will be the case at least into the next year or so as we are in the process right now of also reformulating our strategic plan and vision within ESIP. So we have basically these 4 dimensions that you see here to kind of help define what we mean by information quality. So we look at it from the lenses of science quality, product quality, stewardship quality, and service quality. I would say because we're talking about uncertainty quantification primarily today when it comes to how we encode that information in NetCDF files, that would primarily be within the realm of science quality, but it could potentially overlap because we're talking about data files and data file formatting. It could potentially overlap in these other areas as well, namely product quality, I would say specifically. And what we do as a cluster, I would say, is we primarily are about sharing experiences. We're very open with membership, and you can actually go to our wiki page that you see here, and you can use that to find resources and materials, or you can join our mailing list. There's a mailing list link on that wiki page as well. I'll put my mouse over it so you can see the URL here. And we also are active in kind of co-organizing sessions at other non-ESIP venues. Namely, we've done quite a few at the American Geophysical Union, and we've delivered ESIP-related presentations at some other meetings such as AMS and OGC. The E2SIP is kind of like a sister collaborative organization that collaborates. It's starting to collaborate more with ESIP now, and so they're based in Australia. And so we've had some preliminary engagements with them as well, and also some ongoing ones too. So we have a number of publications that I would say are pretty foundational with respect to just shortly after the establishment of the cluster. So starting in 2016, Peng and co-authors drafted this paper focusing on just high-level scientific stewardship from an open data and big data perspective. And so that kind of ties into the stewardship and perhaps even the product and service quality aspects and going into some of the maturity matrices and maturity matrix work that Peng and her colleagues at NOAA and others have done. And we have this more foundational broad paper that Rama, Peng, myself, and Chung-Lin Shi co-authored, where Rama was the lead author on this one, entitled Ensuring and Improving Information Quality for Earth Science Data Products. So this is really what codifies, I would say, these 4 perspectives that you see at the top here. So if you want to really learn more about what these mean, I would refer you to that paper. And then we have our more recent paper where I was leading that one with a lot of the same co-authors and some new ones as well, entitled Understanding the Various Perspectives of Earth Science Observational Data Uncertainty. We have this on a Figshare ESIP as an ESIP report, white paper, if you will. And I emboldened this one just to illustrate that it's probably the reason why we're having this conversation today is because one of the things we identified in that paper was the need to do some revisiting of how can we better encode the uncertainty information into data files. So as a bit of the scope of that white paper, we looked at a breadth of various approaches covering not just uncertainty quantification, which as you see is referred to as UQ, and then uncertainty characterization, which you see as UC, but also the dissemination and utilization of both UQ and UC information, looking at perspectives of both data providers and as well as end users. And we consider 4 kind of high-level paramount perspectives, foundationally mathematical. That was championed by Jonathan Hobbs. We have the programmatic, which it sounds on the surface like we're talking about software, but what we're actually talking about here is more the governance and perhaps even legal motivations behind why uncertainty quantification and characterization is something to look at, and what initiatives are being done both domestically and abroad to support that from a legal governance perspective, but also from a funding perspective. And so that's what programmatic covers, and Rama was the lead champion on that one. The observational perspective was led by Justin Goldstein, and that one was focusing more on the various types of earth science observational data that we would take into account, primarily focusing on satellite-based remote sensing, but we also had some minimal use cases, I would say, covering other types of data, such as primarily in situ. But I would say the majority of the body of research that was done in this paper was covering the satellite-based remote sensing perspective. And then you have the end user perspective, and that was championed by Bob Downs, really trying to cover the various types of ways in which users might interpret uncertainty information, and as well as how it's being disseminated. So we then identified a set of commonalities and differences in perspectives, and had kind of a summary of where we're going to go from here. I will say that one of the interesting things was that because there was 19 authors total on this, we had quite a bit of various perspectives across all the different earth science domains, covering disciplines such as informatics, metrology, statistics, data science, remote sensing in situ, and also fundamental research. I would say we did touch on numerical modeling just on a cursory level in some preliminary discussions, but we decided to kind of leave that out of the scope of the paper. We are going to revisit that at some point, though. So these are some of the key takeaways from the paper. We determined that the diversity of the UQUC dissemination, consumption, interpretation methods, and there's basically shared interest in all of this, and there's also, we've identified some commonalities in the various approaches therein, and that we also basically tried to capture as best we could the common statistical techniques that are used in doing the UQ estimation and the UC assessments. But we also acknowledge that there's things outside of just statistics, and so we call those out as knowledge-based techniques. And also that UQUC is ubiquitously recognized as a fundamental step toward sort of providing the vital information that helps better characterize the science quality of the data that is collected, evaluated, assimilated, and ultimately applied in the end user perspective. So the other thing here is the ultimate utilization of this information. We found ultimately depends on the effective communication and dissemination of that information. Very few users, we kind of discover this, have a proper understanding of the probabilistic framework. So it's basically what we're trying to say here is that it's more than just conveying the error bars. It's also conveying perhaps the non-Gaussian nature of the data itself as well, or the non-Gaussian nature of the distribution. Maybe thinking about not just the mean of the distribution, but also the tails as well and the outliers. And also taking into account confidence levels and confidence intervals. And on the programmatic side, I would say there seems to be a growing trend in requesting or even requiring the presence of this type of information for specific types of data records, particularly those that contain what we refer to as an essential climate variable, or an ECV. That's actually a term that's coined by the CEOS initiative. So there's also the last point here is that we realize that although we didn't explore in suborbital and in situ perspectives too much, we did realize that they have quite a bit of smaller niche communities, very, very diverse, each of which have their own specific priorities and concerns. And so I think that's one thing that we're going to try to do a better job at revisiting in this follow-on paper that we do. And just a quick slide to recognize the authorship here and the co-authorship of the paper. And then these are the various affiliations. So these are some actions that are going to be beyond this paper. So there is a part 2 paper, as I think I hinted at, that's going to be coming as an extension of this first paper, focusing more on in situ, suborbital, also model and assimilated data. There's a whole bunch of opportunities that I'm capturing here in the second bullet that I'm not going to read aloud, but I will say that what we're tackling today is tackling a big part of that, which deals with the UQ encoding element. That we're going to be taking a look at through this next presentation that you'll see by Ken Kehoe. looking at the NetCDF CFUQ proposal. So some goals of the session, we really want to try to help raise awareness and cross-disciplinary understanding of ESIP's role in advocating and helping to establish best practices and recommendations for UQ information. We also want to help build upon the existing cross-disciplinary enthusiasm about UQ. We want to raise awareness of proposed methods that are proposing to provide standards for encoding UQ information within NetCDF formatted data files. I will preface that while the context of this discussion will be on NetCDF, it's not the ultimate application can go beyond that. So basically any kind of a self-describing format of data, ASCII, HDF included, for example, could potentially be applied with these types of techniques that we'll be talking about. And also to raise awareness of the purpose of CF, potential for augmentation to include UQ data variables and descriptive UQ metadata. Also, I think we want to try to identify and discuss ways to improve the existing draft proposal and basically take it to a point where it's ready to be submitted. Ultimately, we'll be utilizing this forum here to obtain cross-disciplinary community buy-in on how we decide to actually move forward with it. So with that, here's just a quick reminder of our agenda for today. I just wrapped up on the introduction, and with that, we're going to turn it over to Ken, and then we'll wrap up with a discussion and summarize our 3 takeaways. So I'm going to go ahead and stop sharing. And Ken, if you would like, you are welcome to start sharing.
Okay, let me see if I get this to work right. All right, I'm assuming you can see my Chrome window, 3 tabs at the top. Just showing you the agenda here. Reason being is you can then get to the Google Doc. There's a link there. Here's a short link for it, in case you need to type it in real quick. Reason it's in Google Doc is that it will make the ability for you to add comments and suggestions quite easy. And not only is that easy, it's encouraged. So during this process, and the process has probably been going on for 2.5 years, I've presented this to the CF group in the past, and they give me some very good suggestions, which has evolved the current proposal quite a bit. So I've had to introduce a lot of CF concepts where other groups don't use CF concepts. That is probably some part of it where if you don't use CF a lot, you may not understand why certain decisions were chosen. And that is probably more to do with the history of CF and the methodology of their particular standard than any sort of concept of it being the right way, if there is such a thing. So please feel free to go through this today, tomorrow, in the future. This will be open for a little while longer while we try and finalize some of the details. Some of the things that was most helpful at the last ESIP meeting last summer in Tucson were some discussions about edge cases and how to handle some of the more different types of uncertainty information that different groups with different science may have. So one of them was a really good discussion I had with a gentleman about buoy data, which brought up a couple of interesting edge cases where I hadn't really thought about it myself. I'm in the ARM program, the Department of Energy ARM program. I do mostly stationary type data, more long-term series, time series data. But there's no reason that this particular format is only going to work for that. We want it to work for all particular cases, satellite, aircraft, oceanic. And I need help from people to describe how their data currently exists, if they were using NetCDF, if they do use NetCDF, how is your data currently formatted, and how are you currently doing any sort of uncertainty, or how would you want to? Because getting more information really helps to figure this out. You don't have to do it right now if you don't want to, but I did have a section way at the bottom. If you could do this as a poll section, just for curiosity's sake. I have 3 questions in here. Just put a Y and an N in here. I don't care about you tagging, that's you. It's more about the statistics of people in this particular group. So please at some point fill this out. So here is the actual proposal. Let's see if I can get a little bit bigger. Since I'm sharing my screen, you can follow along the screen, you can follow along the document, both ways work. The proposal is currently structured in a way where I have set up some of the history of why it was chosen the way it is. I think that helps to describe why the decisions were made. I'm not going to go through them all right now, but you can read them on a later time or right now. Essentially, some of the ways that I initially thought about this and then the reasons why I chose not to do it that way, which helps, I think, to understand why certain decisions were made and how in certain data formats, a very simple idea doesn't translate into a more complicated methodology for presenting a uncertainty over multidimensional time varying type stuff. And this particular proposal is trying to encompass everything. Difficulty with proposals that try and encompass everything is you never quite get there. You're never at 100%. So it's part of the question then too, is at what point do we say good enough and have to start working towards moving to using it. If we wait for perfection, we'll never reach it. And I think that's where a lot of the examples that we will hopefully have helps to figure out the best way to move forward with the convention there is. So basically, part of the reasons I wanted to know your background in NetCDF and CF is that CF has particular standards for how they do things, and working within their standards means that any sort of proposals will be accepted easier, and also that the standard will work well with their standard. So if you don't use the CF standard right now, some of what I'm talking about, a lot I'm talking about is already existing in the standard. I'm just trying to piggyback on top of it. Some of the initial things I had done was to follow some other formats from other organizations, which required adding a fair number of extra and not necessarily variables, but attributes. And some of the specific rules with CF is that the names of variables are not defined by the standard. The names of the attributes are. So sticking with that methodology, I think is easier for users and for sticking with the convention. And most of the stuff in CF probably boils down to just a few simple attributes, particularly these here, which would be part of the standard. If you don't have a lot of knowledge about CF, go ahead and feel free to drop a question, either by unmuting or by putting the question in. I don't have any presentation. So to be honest, I'm kind of burned out on Zoom presentations. I don't know, this is my third meeting this summer and I'm kind of done with it for a bit. So I would prefer this be more of an interactive thing. So if you have a question or a comment, please go ahead and add it. So basically, if you wanted to read the first paragraph up here, this summarizes how the standard will work. A NetCDF file typically is self-documenting enough where you can do some good work without having to read some sort of ancillary external documentation. That's the intent and the hope of a NetCDF file. The documentation is typically done through, I would hope, reasonable choosing of variable names, although that's not always the case. The use of attributes with specific names indicating what their actual purpose would be. I'm a really strong proponent of good variable names, good long names, because they really help to self-describe. Units are always critical, and some of the things that have a tendency to fall off the wayside when people are building is the concept of missing values. There actually is a difference between fill value and missing value. It's kind of trivial depending on your use of the data. And then there's a couple other concepts here with references and sum methods. But essentially, the basis of this is that you would have a data variable. You would then link to another variable, which is your uncertainty variable. And that's the bare minimum. And that linking is done through a reserved word called ancillary variables. It's essentially just a string character which points to the name of the variable. At that point, you have the linkage completed. And all you need to do is indicate that the variable you're linking to is an uncertainty variable. So that's done through what they have already established called a standard name. Standard name is a lookup table that's outside the file. It is a string character name, which is supposed to be self-describing to some extent, well, what the actual variable is. And then if you were to file that standard name in a lookup table, and there's a number of them online, you would then get a full definition of what that means. In addition to that, the CF convention has something called a standard name modifier. Standard name modifier is actually in the convention. We're currently at 1.8, I believe. And you can look it up, in the standard name modifier does what it sounds like. It modifies the standard name. It essentially appends more concepts or description to it. There's currently a short list, I think somewhere between 6 or 8 of them that have been approved. And my current proposal is suggesting that the standard name modifier is the way you would actually know this is an uncertainty variable. This does not require adding any more attributes. And the concept of, or the point of a standard name is it's supposed to contain a lot of information about positive direction, orientation, what the variable actually encompasses, what the variable does not encompass, and any additional pieces of information you would tack on to a very basic concept. They become more and more specific as you add more qualifiers to the name. I'm not going to go into how the names are chosen or added to the table. That's a whole nother presentation. And kind of want just to jump into, let me just jump into an example, because I think that's easier to understand real quick. And then we'll jump back. So I created this extremely minimal concept here of what the bare minimum would be. And the reason is that you have very little information. Particularly, I would say this is a very bad example, but I see quite often. And that's why I wanted to start with it, to show the bare minimal bones of it. You have a variable, hopefully units, although CF doesn't require, NetCDF doesn't require units. And then you would have essentially a linking to another variable name inside this particular NetCDF file. You would then look at that variable name. It has a standard name set to one of the 6 qualifiers. And that is the full extent to the bare minimum. So you would know this is an uncertainty variable due to this name here, which is a reserved name. That comes, the 6 names which are currently proposed comes from up here. And so these would be the 6 standard name modifiers that would be allowed. And so you'd have to choose one of those in order to define it as an uncertainty variable. And it would be appended to a standard name if you also had a variable that had a standard name. The standard name is not required in CF or in NetCDF. But if you have a definition in the standard name, it's highly encouraged you use it. If there isn't one, you don't make it up. Making it up is actually worse than not doing anything at all, because if it's not agreed upon in the standard name table and is made up, it just causes difficulties and problems, particularly if that name was then chosen with a different definition in the future. So by choosing one of these, you're then narrowing down the category into the basic categorizations of either total, random, or systematic. And then you can actually break it out into specific, total, random, and systematic. One of those 6 would have to be chosen. And in theory, we could have more in the future, but there's the question of how much specificity is actually useful, and at what point do you cross the barrier where it becomes too specific or too much information to process. There is currently one that's out there called standard error, and then this would be deprecated. Deprecated is a term in CF, which means it's not illegal to use, but highly discouraged to be used. Part of the problem is that the definition of standard error does not encompass all possibilities for uncertainty, which I think is what the original intention was when this was created in a previous NetCDF version. I don't know which one it started in. This question from Ed, no, none of them have been proposed as a standard name yet. But more importantly, they're not standard names. They're standard name modifiers. So I don't think you're allowed to have a standard name equal standard name modifier. I'd have to look into that. I would say that would probably be a bad thing if we did allow both of them. In theory, we could use this as a standard name and not a standard modifier. I don't know. I guess I'm curious about your suggestion about whether that is a better or worse suggestion.
So
go ahead. Yeah.
I was gonna say, if you know, we don't have to stick to the precise format of the session. If you'd like, there have been a number of additional questions that have started trickling in. So before going to the next session, I'll leave it up to you to decide if you want to continue with that, or would you like to start taking some preliminary questions?
No, I think it's easier if we answer questions early on.
Okay.
Yeah, hey, this is Ed Armstrong here. Thanks for, I think I have an answer. You gave me an answer regarding my little question I put there in your Google Doc. You know, this is all under evaluation, but I guess I'm not really, the modifier part, I'm not really that knowledgeable about. I mean, these actually look like pretty good standard names to me, as is that you would tuck into the standard name field for a specific variable. But I guess I have to learn a little bit more about the modifier part.
Yeah, that's not a bad idea. I mean, I really hadn't thought about that, but it's possibly a more simple methodology to go that route. So yeah, it's a good point.
And in general, regarding standard name modifiers, this is kind of new territory for me as well, Ken. I'm just curious, is there a database kind of similar to the standard name database where these would reside in? And can you kind of speak to the acceptance process and governance process around if somebody wanted to propose a new standard name modifier, for example, how that would work?
So the standard name itself is proposed through a subcommittee of the CF convention. That's in a database by itself. It goes through small committee. You provide units and a definition, and then they try and look through the current database, which is probably thousands, make sure there's no duplicates and make sure it's specified correctly. The standard modifier would be inside the actual standard itself, like 1.8 standard. There's a table in there. So there's only 6 or 8 of them at the moment. So that would be a change to the actual, to add or reduce modifiers would be a change to the actual standard, which is more difficult than a change to a standard name. They don't ever take away standard names, but they can be deprecated to not be encouraged to be used anymore. They really frown upon changing the definition due to historical reasons. So typically, if you want to make a more specific one or something, you'd have a new one and you can link the two, but they really don't ever go back and change it because of historical data.
That's really helpful, Ken. And I think that that's a really good segue into another question that we have from Rama, which is, can you say a few words about the steps involved in getting this actual proposal approved and adopted?
Yeah, the current governance process is that they've used, they're using ASCII doc, which is a way to create a document by using text files that are then merged together through an actual Ruby script, which then creates an HTML, which then can be converted into a PDF. That particular process means each section is a different text document inside of a GitHub repo. So it's CF Convention has their own GitHub repo. The actual process would be to create a pull request, or even you could actually start the discussion with an issue, have a discussion. Once you actually have something to the point where you want to make it, you would actually edit the document, edit those text files to the point where you're happy, and then create a GitHub pull request. There would be discussion on the pull request as to whether it's valid changes, approved changes. You need to have at least one member of the CF subcommittee or committee encourage the change. If you don't have any actual, like they might be considered voting members, then the proposed change would not happen. But essentially, that is on the onus of the person making the pull request to edit the ASCII doc, which is changing the terminology and the wording of the actual document. And then when they like the state of that, it would be merged as a new revision of the document, a minor document, I would think, minor change, maybe micro. depending on how much change it is. And then it would be published as the next standard.
So as a follow-up to that, Ken, I'm just wondering, has any member of that committee seen a draft of this as of yet?
Yes, I've presented this twice to multiple meetings. This current state, probably not. I made some tweaks, but the general concept, yes.
Okay, so we have a couple more questions before we go to the next section, Ken, if you wouldn't mind. So this one is from Peter Killick. Its question is, so you're proposing implementing an uncertainty variable quite similarly to how bounds variables are already implemented. Is that sort of correct?
I wouldn't say it's a uncertainty variable. It's similar in the concept to the bounds dimension, where you basically have not just a single value, but the lower and upper limit. So yes. Okay.
And let's see, we have one more question from Yakshin. It's how many specific underscore asterisk uncertainty can a variable have?
I think I understand the question. So you can have one, here, I'll show you real quick here. You can have standard name equals one classification, but an actual variable can have as many different uncertainty variables as they want. So maybe this is a good transition to do one more step through the standard, and then I'll come back to that question. So one additional part, which is an actual cell methods is an attribute reserved. Cell methods is devised to describe the variable, hopefully in a machine or semi-machine readable way, which describes how the variable was derived. I am proposing there would be 4 additional cell methods added to the list, which would be these 4 here. And in order to follow the GUM recommendations for deriving uncertainty, GUM says there's basically 2 different large class categories, type A and type B. Type A would be statistical in nature, type B would be not. Statistical in nature is a relatively small, it's not infinite, but there's a large number of them out there. And so essentially you would have, and this is only the first, basically 3 that I proposed, ways of deriving a value, standard, confidence, or with at maximum. And then type B is some other methodology, which is basically at this point just a catch-all. It's basically saying it wasn't derived via typical stats methodology, but it's still a reasonable expert-derived opinion on an uncertainty, which can be very helpful for depending on your analysis of the data. And so essentially, this is a way to group things into the derived methodology. And then if you would have something like other than statistical analysis, you would then use another word, which is either you could use a comment, or you can point to another document, which would actually have the full derivation of what does this mean, or don't. That's dependent on the person who's writing the file as to whether they think that's worth their time or worth adding. So for example, here, this one actually has a better described variable. It has a decent name, it's got units, it's got an actual standard name. This is the data variable. And then it links to the uncertainty value. And then because the value has a standard name, we basically would tack on random uncertainty. And that's the good question that Ed raised, is whether we would want to continue this or not. And that's something we probably should think about. The cell methods here says over the time dimension, this essentially is a standard deviation. And then the reference attribute says, if you really want more information, this is how it was derived. References would be pointing to some sort of external thing, not within the file. So to get that, the question is, you can also then have a data variable, which would have multiple, in this particular case, is pointing to 4 different values inside that. 3 of them are associated with uncertainty. Your random, bias, and then total. And each one essentially is its own variable, with the only requirement being you have to have the standard name equal to random uncertainty. And then these here are optionally telling you how it was derived. And you'll see that each one of these is slightly different. So in this particular case, the random and bias have a dimension of time, but the total is a scalar. So I have no limits on how these things are derived or how they're presented. You could do scalars, you could do variables that are multidimensional, and you can link to as many as you want. You could have different ways for deriving the bias. And so in that case, you could have 3 different variables with 3 different methodologies of how you would derive a bias uncertainty. Or the total could be derived using 3 different methodologies, or 10 or 100, whatever it may be. So it doesn't provide much restriction as to how you derive, not even the methodology, but it does try to provide some additional pieces of information, which gives you a little bit of help. And then it's up to the provider as to how much they want to provide. Hopefully providing things via DOIs so the linkages don't and so forth. I hope that answered the question. And so that's kind of the extent of the particular proposal. The rest of this is actually a bunch of examples. And maybe we could answer some questions by going through examples.
Thanks, Ken. You answered my question. And we have a new question or comment from Ed. So Ed's comment is, I think that standard name modifier should be optional. In some cases, it might add value, but for most, just having the bare standard name is enough.
Yep, that's just my take. I mean, I think kind of the modifier part, it makes it more descriptive, but in another case, other sense, kind of maybe overcomplicates it. I'm kind of like on a little agnostic point here, but you know, certainly I haven't quite come across the modifier part or leveraging the CF modifiers in the past, obviously. And actually, I don't remember like coming across too many examples in the Earth Science NetCDF world of seeing that. Maybe I'm wrong on that, or you know, maybe it's used more in the modeling world. But I think just having the bare kind of standard name from that list there, total underscore uncertainty, and all the other 6 ones associated right there as a standard name attribute inside the variable was enough. So that's just my take on it.
It makes sense. I mean, if you have a standard name attached to the data variable and a linkage back to the uncertainty variable, you can infer the standard name. So that makes perfect sense.
Yeah, exactly.
That would make the request a little bit easier too.
That raises another question for me is there might be some cases where you might have an uncertainty value that represents, let's assume we go with the standard name modifier approach, which could be an option. You could potentially have a standard name with multiple that corresponds to, or you could have an uncertainty value that corresponds to multiple methods of uncertainty quantification that have been utilized that would then potentially result in the utilization of more than one standard name modifier for a particular uncertainty variable. Does CF have a restriction if we were to then decide, let's go ahead and use just the regular standard name as the attribute? Does CF have a restriction on how many standard names you can use for the same variable?
In one variable, one standard name. You're not allowed to have multiple because the concept of standard name is that it's unique. You can't have 2 different ways of describing the same thing. Okay,
so it seems like one potential advantage with the modifier approach is the flexibility of attaching multiple modifier attributes to the same variable. If that use case was applicable.
You can't, so you can have multiple variables all having essentially the same concept of total uncertainty or same concept of atmospheric temperature. But each one is an independent variable. It's not possible to stack up
I see.
Multiple standard names or multiple modifiers.
Yeah, I think another reason why, so I work with Ed, by the way, in case people don't know. I think another reason why we haven't generally seen the standard name modifiers in practice is because of the newness of it, because I believe, according to your introduction, Ken, it was introduced for the first time in CF 1.8. Is that correct?
The modifiers?
Yeah.
I don't know. I don't know when they were introduced, but it's been around for.
Okay. It's been around for a while. Okay. All right.
Any other questions we want to talk about, or otherwise I was just going to step through some examples just to get opinions on the difficulty of understanding the examples. Okay, so in this particular case, so multiplier with standard deviation. This would just basically be a standard deviation derivation of uncertainty, but the value provided in the file isn't a single standard deviation, it's actually a multiplier. This was presented to me as a possibility, so this is my way of solving that problem. This is, some methods has an option where you put things in parentheses, which are qualifiers on top of this derivation methodology. And this basically is the dimension and then the method used. And then you can have, I don't think there's a limit to the amount of information that would exist inside the parentheses. For confidence intervals, it's pretty critical that you know the confidence interval. Otherwise, it's not really a confidence interval. If you choose to tell the user in the cell method that it was derived via confidence interval, this would be some sort of requirement of saying at what level. If you then also had time varying confidence interval, the proposed method of solving that issue, because this essentially is saying everything for this variable, whether it's a scalar or a vector, is all at 95%. But if the confidence interval range actually changes, then you would actually have another variable, which would be dimensioned by time and would have the confidence interval per time step. So once again, we're linking from a data variable to the uncertainty, from the uncertainty to a confidence interval. That's a pretty common way of doing things in CF, and I think in NetCDF in general, is when you got multiple variables all dimensioned. Each one gets its own variable. It's really messy fast when you start slamming dimensionality variables inside of the attributes underneath the variable. It doesn't scale well. So for existing sum method methods, which exist, you can provide information. For example, if the uncertainty was derived via a variance, you can then say over what interval, and essentially this concept would be a running variance over a running window, the interval of 1 hour. And these are all concepts essentially where you would have no linkages to the outside world of this file. The concept being that the NetCDF file is self-documenting enough that you can get everything out of it. The alternative is just point to a reference on the web that describes the process. And it really depends on what is your intent. You can have a machine read this if this is important to provide some sort of decision process. And that's the point of having it in a mostly machine readable methodology. So like interval is a reserved word. This is a reserved word under units. So it's not easy. It can be complicated, but it's possible. One of the other ones that was really interesting was qualitative. So how do you do something that's not really continuous? This is information provided by an expert through some methodology, which doesn't necessarily have to be defined. You can take their word for it. And this one would be using the state fields. So essentially you have your standard state methodology of flag values or flag mask. This then corresponds to a flag meanings to describe what those values mean. And so here you would have a variable, just dimensioned by whatever it is, where you have these options for numbers, 0, 1, 2, 3. And then essentially it just links up in a one-to-one relationship. This one you have to parse because of the current CF convention not allowing strings. Everything is a character string, but you essentially parse this at the space character. And so then 0 is no confidence, 1 is low confidence, and so on and so forth. The thing you hope for is that the person creating this would create a flag meaning that would provide enough information for the user to actually understand what they mean. Most of the time this works well. And this probably gets back to the question you had about the asymmetrical. So what happens if the uncertainty is different for the upper and lower bound range? And this follows along the current methodology that CF has for time dimensioned, where you can have a bin value. And so you have basically the lower and upper bin range. So now you have something, and the names of these dimensions don't matter. I just called it ASYM. It could be bin if you wanted to be consistent with the other time bin. But essentially provides a lower and upper value, which can be different per time step, or even a lower upper value for a scalar. So essentially you wouldn't have time dimension. You would only have the dimension 2, the bin dimension. Everything else would stay the same. This particular proposal would say, you have a data variable by time. You have, it started off with the same dimension, and then there's a dimension of 2 in the backside of it, on the end of it. That tells you this is asymmetric and how to move forward. And in this particular case, it's not dimensioned by time, but is asymmetrical. Since time is much longer than 2, and you also know in that NetCDF file, the actual dimension names, you can figure that out pretty trivially. The only thing that's probably different than other places, and maybe something to discuss, is my suggestion would be that the lower bound, let's call this the 0 index and this the 1 index, or sorry, other way, whatever it be. Everything is positive with the assumption that you always subtract from the value for the lower bound and add for the upper bound. And that would just be part of the standard you'd have to understand. That part would not be in the NetCDF file. And you would have to understand that's the convention. For the buoy data example I was given was that the data value actually doesn't have uncertainty. It's actually the positional part of it that has uncertainty. And so in that particular case, the data wouldn't have uncertainty written in the file, but the location aspect of the coordinates would. And so essentially the logic would continue with the same methodology of just proposing uncertainty on top of the location coordinate variables. And then probably the one that is a little bit more difficult to understand, but I think would be applied a lot, is the idea that you could have a scalar uncertainty that applies for a duration in time, and then that scalar would change. So for example, in my case here, time is quite large, 120,000 values. And that particular uncertainty would last until another time. And then we have better data, better instruments, and the uncertainty in that particular value would change. Instead of forcing the person to write 120,000 uncertainty values that basically repeat themselves, is there a way we can compress this? So my idea here is, one second, I gotta handle something. Sorry, my son had to show me something. So in this particular case, you would then also be linking to an external file. CF does allow you to link to an external file. It's not fully defined how you do that. That's the one downside to it. One big plus to it is that you can see the size of these files will be drastically different from 120,000 to 2. They also can exist at different time steps. You can create this uncertainty file at a later date, which I think is typical for how you're going to derive an uncertainty. You're not going to know that at the time of data measurement. And it can be updated independently. So as you provide more analysis, your understanding of uncertainty evolves at a different rate than the data. And so you would have a better understanding of uncertainty as time evolves. So in this particular case, you would have an uncertainty of 0.01 for this particular value, doesn't matter what it is, up until this point. And then starting after that, up until that point, you would have a different value. And so this would allow for a significant data compression of a value, particularly in this case where it's scalar, and you don't really want to dimensionality it up just because you want to write the same value 120,000 times. So those are the current examples I've gone through and provided suggestions for how you would handle them. Like I said, the best help so far has been other people looking at the standard and saying, how would you handle this particular edge case? How would you handle this situation? And seeing if this particular standard would hold. If it doesn't, then you may have to find an addition or a tweak to get the standard to work. If you have suggestions, I would greatly appreciate it. You add it to the bottom here to say, how would you handle this particular situation? That has by far been the most useful piece of additional information I've been getting from users after presenting this a couple times. And that's about it.
Okay, Ken, just one quick comment here from Ed Armstrong again on this example of the wave uncertainty where it's a singular value and you want to put it in an external file. But to be honest with you, this example here where you have 120,000 data points, right? So even if they were all captured in one variable, right, 120,000 singular values, they would compress down to nothing if you turn on the NetCDF4 compression. So even though it seems like there's a lot of redundancy, from the perspective of the actual file size, it's gonna have pretty much zero effect.
I agree. Yeah, when you add compression to a NetCDF file, it does extremely well. My particular organization frowns upon the use of compression due to accommodating users who don't have the technical know-how or the higher level, more recent libraries.
But with,
so yes,
with
I agree.
NetCDF4, it's all built in, right? I mean, every kind of native NetCDF4 library or extension of the library and like third-party systems like IDL or something, they all have like just simple like command line flags or something to do the reading or the writing. It's pretty simple.
Mm-hmm. No, I totally agree that is a very simple way. My program currently does not allow NetCDF4 except for certain files. They're stuck in NetCDF3 because of our user base.
I see.
So trying to accommodate everybody, it's really hard. That's a difficulty. It's older. I mean, I wanted to have the ability to use strings with the attributes, and I've been fighting that battle for 3 years now with CF. And they will not allow that because of difficulties with, I think, the C and the Fortran compilers not understanding the difference between a string and a character at the attribute level. And so I'm stuck, not allowed to use string arrays with attributes. And I have the same argument, like the NetCDF4 allows it, and the modern languages know how to parse that. But they say no. So I have to have workarounds.
I had one other question. If you want to go back to the list of the uncertainty attributes.
Sure.
The list of 6 there. Just had maybe clear up a little bit of confusion when I was looking at it a little more closely. Yeah, these ones right here. So when you're looking, okay, the systematic underscore uncertainty, also known as precision or bias uncertainty. To me, if it was going to include both precision and bias, that would be the total underscore uncertainty. And like the precision and bias are separate. So where are they like captured in these top 3 right here? And maybe just focusing on
Yeah, this might be a terminology thing. I saw the words accuracy and precision and uncertainty used in a previous talk. I was confused because I used the terminology of random and systematic. So maybe that's something that I shouldn't put in here. And just
well, for example,
as random and
I work with this one satellite data stream that has two variables. One of them is called bias error, and the other one is called standard deviation error. So of course the bias is like the offset, and the standard deviation is kind of like an overall, total precision, both algorithm and environmental, errors that creep in. So where would those two variables then, how would they be tagged, you think, with this from this list right here? Because it wouldn't be total underscore uncertainty, and then, what would be your recommendation?
It's hard because I don't know what they mean by, you said it's called a standard deviation uncertainty?
Yeah, it's a single sensor error, standard deviation, right? And the other one is bias. So,
typically, if you provide me two different values, one of them is called bias, I consider a bias a systematic.
Right, okay.
And usually,
the
standard deviation is a measurement of the random processes on top of some sort of mean. So my personal interpretation would be random, but without more information, it's really hard to know.
Okay, so I agree with that, but what kind of threw me off is you have the word precision under the systematic uncertainty, right? So is that correct? It seems like precision is, the systematic uncertainty is, like you said, is like the bias, right?
Well, yeah, the systematic is the bias, right? Looking at the word I don't know. That was presented to me in a different presentation, so I was trying to be more clear.
Yeah, so I think maybe the message, the take home message here for me is there's room to polish up some of the terminology and how we explain the terms. I would say that's one area to focus on as far as some of the next steps. Is kind of getting into maybe some of the next steps here. And we have some data scientists and statisticians from the uncertainty white paper that was published last fall that I would welcome to be brought into looking at these terms and making sure that from a mathematical perspective, the way that they're being defined is consistent. I definitely see Ed's point about precision, and I would generally agree with that precision is probably more associated with the random uncertainty through kind of like a standard deviation approach, or maybe a root mean square error approach. But there is also, I could see the argument where one might say that precision is systematic from a sensor perspective. So like there's certain sensors that systematically have a preset precision value, right? So maybe that's one of the perspectives there. So there's precision at the sensor level, but then there's also precision once data becomes reprocessed and aggregated and assimilated. Then the sensor precision is less important than the actual precision of the final product. I don't know. It's something that we need to explore. I can definitely see.
I think that's why. I mean, when I presented this, that was the reason that these three were added. Is that when you're saying any three of these, they are on the data, period. I don't care how it was derived or whatever it is. I'm presenting data, so the uncertainty I present has to be on data. And it's more of a total systematic, total random, and total uncertainty. There is a possibility, I think, of what you're talking about, David, which is a uncertainty which could be the random, systematic, or total of a particular component of the data value, which would be sensor or environment or mathematical or whatever it may be. And that was the intent of adding the specifics. And you could have 6 different specific random uncertainties for one data variable if you have 6 different ways for uncertainty to approach into that data variable. And so I think that's where different people have different opinion on uncertainty. and whether you, and at what level, how much detail do you need to know? And there's no right answer to that, because different researchers have different opinions and different needs.
Right. So I wanted to see if maybe we could circle back to when you in the earlier drafting stages of this proposal. You mentioned that you were able to get in an earlier iteration, you were able to get a CF committee member to at least take a look at it. Have you had any actual earlier review, whether it was a reviewer or maybe a contributor, or can you kind of walk us through what that experience was like in those earlier stages, and how many people would you say were involved in helping you draft this?
Oh, I got to jog my memory here. So initially, I would say my proposal was more similar to the convention for my program, which is not heavily dependent on the terminology used and the attributes used for the CF convention. I was probably more close to the CloudNet methodology, my first iteration. And essentially proposing lots of attributes, that's hard to get those accepted. And so sticking with the current attributes was a lot of the push that I got. Not to make much change, but essentially to tweak the existing infrastructure and use it and define how it's used in a particular way was the way I got pushed the most by the current CF convention members. And that's probably how we got to where we are now, with no attributes being defined at all, and using the existing ones with just some small changes to their definitions or their allowed reserved words. Probably, I would say major revisions, I'm probably at 3, a bunch of micros on each one.
Right. So I think it's probably helpful for the people listening in right now to be made aware. It sounds, and correct me if I'm wrong with this messaging, Ken, but it sounds like this is probably at a really interesting point where you have the opportunity to have the greatest amount of eyes on this in terms of a cross-domain, cross-disciplinary expertise perspective. Would you say that is pretty accurate?
I think I understand the question. I would say at any point it's awesome to have that many eyes giving suggestions. I would say at this point, the proposal is taken into consideration and able to handle every case that I've been presented so far. I think that's answering your question.
Yes, thank you, Ken. So maybe what we could do now, I don't really see any new questions trickling in, is maybe what we can do now is, since we have about 24 more minutes left in the session, is focus on or try to identify sections or aspects of the proposal that we want to maybe focusing on, whether it's polishing terminology. I think we identified that one as one thing we can contribute toward. Another one is maybe revisiting whether we decide to use the standard name modifier or the actual standard name itself. And so I think that maybe those two things are what stood out to me as things that we need to maybe take a closer look at. I guess my my one concern about the standard name versus standard name modifier is that if we do go with the original proposed approach that you have here, Ken, with the standard name modifier, is that it's kind of like a one and done thing that would be iterated after it's approved. Whereas if we went the route of standard names, you're now creating multiple moving parts in the process. As anyone who's gone through the standard name approval process knows, that it's a little bit of a black box, number one. Number two, some standard names are approved before other standard names are approved, because each standard name proposal is represented as a disparate proposal. I don't think there might be some edge cases where people have proposed a bulk set of standard names, and maybe that's a viable option. But again, you have the separate moving part of that versus kind of this higher level notion of capturing uncertainty at the variable metadata level that it sounds like still needs to be done at a minimal level in terms of the CF 1.8 proposal. Again, is CF 1.8 what you're targeting for this? Or is it 1.9?
I actually don't know which number. It would just be the next one.
Sure. But yeah, so I think that maybe what we could take a look at, Ken, if you can maybe scroll up a little bit, is you talked about some of the minimum, before you even went into the standard name modifiers, there was like a minimal level of information that you would be proposing. Mm-hmm. And I guess the question is, if we went with the standard name approach for the uncertainty variables, as opposed to the standard name modifier approach, would we still have to submit some basic, just to satisfy these minimum requirements? Would in your opinion, that be still required to go through the CF convention process, or would the standard name approach be enough? That's the part that I'm not so sure about.
Yes. So, well, it's a little bit dangerous to essentially change the CF convention via going through the standard name subset without then also having a description about how to properly use that standard name. So if we were to use these as essentially 6 new standard names as the methodology to define a variable as a standard name, as a uncertainty, this essentially would work the instant that those standard names are approved, which happens every month. And you can submit all 6 for a bulk revision. And that would probably work easier and probably work well. My concern would be people not understanding the correct way to use this. Particularly the fact that this is a requirement if you're going to use this. That part is not part of the standard. So that would be the one part of standard that people could get wrong if they don't use this particular standard correctly. So I do think in order for it to work right, both have to change. But it would be easier to just get 6 more standard names than to try and get 6 standard name modifiers, for sure. Significantly easier.
And you could submit that as a bulk request?
Yeah, you can basically, I could point to this document and say, I'm proposing these 6, comment on all 6. It essentially is an all or nothing.
Yeah, so I think you answered part of my question. The other part of the question, maybe it wasn't very clear, was assuming that you do go that approach of the standard name approach, not the modifier, but the actual standard name approach. Is there still, are there still missing pieces? It sounds like there might still be some missing pieces that would still necessitate a NetCDF UQ proposal just to capture that bare minimum set of additional attributes that you were touching on. Do I understand that properly?
I think there is a change to a couple of things in a standard, which would be these, which are actually the list of cell method reserved words. That would be part of the standard, not the standard name change. Only reason that they need to exist basically is this concept of self-documenting with the NetCDF file, which the current way of saying how did you derive this value is via cell methods. If that's not important, then that part wouldn't have to change.
Yeah, no, I think cell methods is very important. It's just a question of do we consider it mandatory to be CF compliant?
Well, no. So yeah, you don't have to write a cell methods attribute for it to be an uncertainty variable. Same as you don't have to have a cell methods for it to be CF compliant. Cell methods is strongly encouraged when possible. So there will definitely be cases where you would have a derived uncertainty value that wouldn't fit within the existing, there's more than these, reserved words for cell method. And that's part of the question, I guess, is some people, some users would never care about this. They don't care how you derive the value. You are an expert, you have this value, they're gonna take it on faith. And there's others who will say, I need to know the exact full description of how you derive that. And the world is some sort of distribution between those two. So the standard is less about telling people how they have to derive the value, and even a little bit less about how they have to present it, but give them enough options so they can do what they want.
Right. Right. So there's a number of CF attributes that are, I would say, in the category of being optional. I wouldn't say there's a lot of them, but there are some examples of those already. And I would imagine that for those even to exist in the context of CF, there had to have been some proposal for it to get there. And I would say that even if we were to agree today that let's just call these optional, you would still have to submit a formal proposal. Is that correct?
For changing the convention, yes.
Okay. Right. The other point I would make too is regardless of the route we go with regard to whether we choose standard name or standard name modifier, I would say that this document itself would still be extremely helpful at providing the contextual background to motivate why we would want to do that. So in either case, I would say this document itself is extremely helpful. That would be my opinion on that one. And so, because a lot of times with these standard name proposals is you have all these back and forth emails of people wanting to expand upon why they're proposing a new standard name. And I would say we could just redirect those questions to this document itself, and maybe use the document itself as a way of addressing some of those. That's of course if we choose to go that route. Yeah, so at any rate, I'm just doing another time check here. We have 15 minutes left in the session. I don't see any additional questions coming in.
David, I have one question for Ken. Are you soliciting use cases that can be used to test your proposal?
Absolutely.
Have you maintained a repository of such use cases?
Essentially, this document's examples plus the very bottom of the document is where people have been presenting them to me. So yeah, add it to the bottom of this document and we'll try and find a way to see if it works.
Yeah, there is one use case that I can think of is actually an example from a data product produced and distributed from the Oak Ridge DAC. It's called DayMet. It's a daily meteorology graded product derived from assimilating in situ observations. So you can consider that as a graded product derived from local ground observations. And there is a type of uncertainty produced for that dataset, but not on the pixel level because it's difficult. So they used a cross-validation process to assess the uncertainty associated with the graded product. And currently, the cross-validation uncertainty information is stored in a separate set of data files, different from the data files that contain the actual credit estimates. I'm not sure if that's something in your consideration for a proposal.
I'm not.
Yeah, so if I understand the question correctly, actually, what you're talking about is a use case in which the uncertainty information is provided in a separate container file, if that makes sense. Is that kind of what you're suggesting?
Yes, it's in a separate container file, and also it's derived using a cross-validation methodology. It's different from the typical method to get the uncertainty, say, at the pixel level. It is not, the cross-validation is not at the pixel level. It's still at the individual site locations.
Yeah, I would say whether it's at the pixel level or not, I would say that's probably lesser important than the fact that it's being represented in a separate container file. Because I think what we're trying to advocate for here is having the uncertainty information co-located within the same file as the actual data. So it's an interesting use case, but if there's a way to kind of circle that back in some way that provides some sort of an advocacy for those types of data providers to consider having a common file, a common data file for both the uncertainty and the data, I think that would be more in alignment with kind of what we're trying to do here. Would you say that's true, Ken?
I'm trying to think about how you would encode what was just the example. I see no issue with it being external. CF allows external. This particular proposal would allow external. It's encouraging to merge them. So if there was, I guess in that concept, you're saying that there's no intention of merging the uncertainty. Is that what you're saying?
Currently, no, because this one is a graded product, the other is more of a discrete. Is that the right term to use in the CF context? Like point-based discrete data.
Yeah, a discrete geometry, correct. Yep.
So theoretically, I think, NetCDF, you can put everything together, but is that a really good practice to do that?
I think it's doable.
Practice is up to debate. I mean, it's everything is up to the data provider and what they want to do, and what they're capable of doing. I think you have a good question here. Again, it's actually two different use cases, I think, because you could have the case where the data provider never intends to merge the two, and that's okay. That is something that the standard in CF allows.
Right. Not at this point.
And so the other question there would be, is it in NetCDF format?
They are both in NetCDF format. Okay. Actually, we assigned two different DOIs to two different products.
But that's a good question you raised there. Is it possible to have a NetCDF file with data that would then link to an external resource where that is not in NetCDF? And that would be discouraged, but there's nothing in the standard that says you can't do that. The question is, how would you put that in the data file, NetCDF file, so that's easier to understand that that's what's going on?
That's a
and that one I haven't thought about.
Your comment just now reminded me the polling questions that you put out at the beginning of the session. You asked if people want some standard for other formats.
Yeah, so the concept here was, are there key concepts that we're talking about here which could be applied to other formats, not NetCDF, that is important, ASCII or something?
And a question that I just came up was, I was wondering if you had the intention to crosswalk there's different uncertainty representations in different formats. Like you just point out, there's uncertainty information in a separate external file in different formats, and how to link to that information from NetCDF or from another file format.
Right.
I could jump in here with this one. So we have some existing use cases at Podak where we've successfully done this with ASCII data using what's known as the YAML encoding format to describe the header information as well as the variable level attributes. And it made it all CF compliant. And the other point too is that HDF, I think, can support it natively without any additional augmentation to the foundational data model for HDF, is my understanding. There's a lot of similarities with HDF and NetCDF, especially once you go into NetCDF 4 versus HDF 5, it's virtually identical. Beyond HDF, NetCDF, and ASCII, I would say, okay, it looks like JSON is being, JSON is considered. I would say theoretically you could do it with JSON or XML, because those are like a type of ASCII format in a way. But is there a specific format outside of that range of formats, Yakshing, that you're concerned about?
I think you covered a lot. And at ASCII, I think there are a number of, I'd say lower level, not lower level, but some refinements of the ASCII format. There are different types of ASCII format. We have the iCart format for observation data. And that's actually one type of ASCII data, but they call that iCart. But the point is, iCart defines a set of elements in the header section that can provide some additional metadata information to define the contents in the ASCII file itself. So it provides a template that additional attributes or elements can be added to further define some information like uncertainty.
And, this is Ed here. Don't forget about ZAR and cloud optimized GeoTIFF, right? NASA is carefully looking at cloud optimized GeoTIFF. I don't know if anybody really has a good working example of encoding uncertainty information in a GeoTIFF file. So consider that use case too.
Good one to consider.
Mm-hmm. But I think the core of your question comes down to the concept of, is this okay? I mean, there is minimal, if not no, metadata information associated with this example, which is a real life kind of thing. We run into this all the time. If that's true, that this is okay, then I think as long as you can match up dimensionality wise, then any sort of format works. Because that's the crux of it at this point, is I have no information in this example, how it was derived, how to apply it, time range of what it was applied over, all that kind of stuff that is important to understand to a large number of people. But it's also a large number of people who don't care and would be completely happy with this example. And if that's what a provider provides and that's all you got, you're probably going to go with it.
I think this example you currently highlight on your screen provides a nice example. Simplification is really good. I think one assumption here is the terminology is agreed in the community, and there's no confusion about that.
So in that particular case, the only linkage back to CF at that point is if we do a standard name and not standard name modifier, is that the lookup of this terminology, which defines the variable, is done in a standard name table, which is associated with CF. And I would assume they would be cool with that. I don't see any reason why you couldn't do that. from another community would use a different data format. And if somebody chose to do that, it would work. And so the question there is, do we allow this cross-linking between a JSON community who's pointing to a NetCDF standard name lookup?
Thank you, Ken. So in the interest of time, this is really great discussion. I just want to remind everybody, the session is scheduled to end in about 2 minutes. Maybe we can just start shifting gears now to kind of finalizing our key takeaway points here, Ken. So thank you for that, Ken. I'm going to go ahead now. Ken, if you could maybe just stop sharing for the moment, and then I'm going to share my screen here. Perfect. Thank you. All right. So so for some key takeaways, we're kind of going to be doing this on the fly here. Oh, by the way, this is some really good information for you, Ken, as well, regarding the poll section. Sounds like we have a majority of people that use NetCDF and CF, as well as desiring uncertainty in various formats, which is great feedback. So let me go over to our takeaways section. Let me find that first. I got a little lost here, sorry. Here we go. All right, so I'm gonna make a new bullet here. So I think it sounds like we all agree that one area is polishing the terminology. Another one that I captured was need to get some consensus on where we go with regard to using either the standard name modifier. This is the actual standard name. And the other thing is, I'll just capture this as part of a sub takeaway, that in either approach, the proposal itself contains some optional metadata attributes that would still require submission of a formal CF proposal. I think one thing we haven't really discussed was the timeline of when we would desire. I think maybe, Ken, we would probably defer to you on a proposed timeline. But maybe we could just say that whatever that timeline happens to be, we should maybe think about having a coordinated effort where you have a little bit more support from the ESIP side with the people that we have here that have joined us. And with that, I would say if anybody is interested in continuing with this proposal, because we are going to run out of time very soon. We're already 1 minute past. If you could, at the top of the page here, I'll just show you an example under this attendance list. If you could just say yes, just to indicate that you're willing to continue these conversations to help us reach kind of a decision on some of these key decision points. It would really help Ken out, I think, to have that level of support. And then as we follow up back with you, it helps us know who to follow up with. Yeah, that way we can have a little bit more closure as far as the coalition of support that we're trying to establish as part of the goals here. And maybe Ken, I could just say need to establish a timeline for submission. Beyond that, does anybody have any? Well, first of all, are we okay with these takeaways? Is there anything that we're missing?
Yeah, I think David, maybe I know we're kind of running out of time here, but I think, maybe, kind of like setting up kind of a stricter timeline for, both reviewing Ken's document and, whatever kind of assistance he might or support he could get from ESIP in the submission process. I think would be a good thing. So,
yeah.
As the chairs of the informatics cluster, right? Maybe they, after this meeting could kind of circle back and kind of come up with maybe a more kind of defined timeline. So this thing, starts to, I think it has some momentum now, but yeah, we don't want to wait like another 6 months until the next ESIP winter meeting or something like that.
Right.
I think you guys want to get some support and keep the momentum going.
Absolutely, and that's why so with your feedback, Ed, thank you for that. I included the words community review within that timeline. So we need to have a timeline capturing community review as well as submission. So I kind of look at this as kind of the first step towards community review from the ESIP perspective, perhaps. And so I would actually first defer to Ken to kind of carve out a drafted timeline of these things, and then from that, I could forward that to the ESIP information quality cluster, and then we can review that internally to see what capacity do we have to support that timeline, as well as what is the level of interest. Because obviously there's a number of people in that email list for the information quality cluster that were unable to make it today to this session. So it's a good way to fill them in as well and see if there's additional people that we can bring into this. Is there anything else you want to add to this, Ken?
I don't think so.
Okay, so with that, we're 4 minutes past our allotted time. I want to thank Ken again, and also thank Yaxing for helping to field the questions and taking really good notes. With that, feel free to email myself or Ken. Our emails are at the top of this page here. And if you, again, want to be involved in this moving forward, please make sure you include your email address in the attendance list, and just mark at the end of all of that, just mark yes to indicate whether you wish to be contacted for future collaboration on this effort. So thank you again, and we will conclude.